The type of question we find here is about given ratio, and then you have to find the area of triangle. For my convenience to talk about this section, and I will use SE to denote the area. For example, I will use S triangle ABC to denote the area of triangle ABC. There are two important techniques that you need to find the area of triangle in this particular question. Type number one, they are areas of the same height. For example, you have a very big triangle called triangle ABC, and then so there's a line AD which cuts the base into BD and DC. And now I tell you that, for example, BD to DC so is equal to 2 to 3. The concept as follow would be, because you will see that for triangle ABD, the height will be H. Similarly, for triangle BADC, you will also see that the height is also H. So when we are talking about the ratio of the area of triangle ABD to area of triangle ADC, or even to area of triangle ABC, so you will see that so it's talking about the base BD and the height, which is called H, and then divided by 2. Then the other ratio would be DC, height the same H, then over 2. And finally, you also have the base called BC, height H, and then divided by 2. So afterward, you will see that when we cancel the numbers, cancel 2, 2, 2 in the ratio, as well as H, H, H. And then you finally see that the area, the ratio of our areas is actually equal to BD to DC to BC. So after you understand this concept, we can ignore the idea about the height, so that you need not to consider base times height over 2 as the only rule to find the area of triangle. And yet you will see that because of this idea, we have a very important result that the ratio of the areas of the triangles is indeed equal to the ratio of bases of the triangle. The second technique is about similar triangles, which normally happens when you have parallel lines in the questions. So for example, now you have a butterfly shape, so which you have triangle ABC on top and triangle ADE at the bottom. Right, next you should observe that now you have triangle ABC because of parallel, and then so angle B is equal to angle E, angle C is equal to angle D, while angle A, they are vertically opposite angles. So now you've got the triangles are similar. Now, for example, if I tell you that AB to AE is equal to 1, 2, 3. Next, the area of triangle ABC to the area of triangle ADE, so it's equal to 1 square to 3 square, is equal to 1 to 9. So which is a concept you have learned in Form 3. Next, we read some examples to illustrate the concepts or two techniques you have learned right now. So in a question as follows in 2012, so you see this is a question of a parallelogram. So the most important thing that you see the question is about ratio, 3 to 4, 1 to 1. And you are talking about area of triangle, so which is 3 cm square for the triangle called DFG. So when you see this kind of question, ratio, area of triangle, and at last you are going to find area of some other thing. So this time it's asking you about ABCD. So this is a question which is about the two techniques we just mentioned. So how about we just first of all write down the ratios in the figure. So I have DF to FC is 3 to 4. And then so this is my habit. I like to use a circle which indicates the ratio in the question. So afterward, where I also have AD to DG, so it's equal to 1 to 1. And then next, you have the area of triangle DFG, which is 3 cm squared. So I use a number with the circle to which denotes the exact value. Now in the question, you will see, so how about we look at the base called DG and AD first. In order to use technique 1, you need to add the line called AF. Because when you try to turn the picture, you will see that the triangle, okay, let's have some colors. So when you see the triangle ADG and also triangle ADF, so they are sharing the same height. So, and because of the ratio 1 to 1, so as a result, the area of triangle ADF will be equal to 3. Similarly, when you turn back to the original orientation, okay, so now we've got area of this one is 3. Next, by similar idea, so now I'm focusing on, okay, how about I use green in color? DF ratio 3, FC ratio 4. So as a result, I need to add a line. So can you figure it out which line are we going to draw? So it's the line called AC. So that this time, if you have area 3 for ADF, and you have area is 4 for the triangle AFC, because the ratio now we have ratio 3 and ratio 4 here. At last, in order to find the area of the parallelogram, so now we are still missing one part, which is the area of triangle ABC. And here we need to use the property of parallelogram, which is we have got area of triangle called ADC is equal to 3 plus 4 and is equal to 7. And can you recognize that the area of triangle ABC so is also equal to triangle ADC, which is also 7. So as a result, the area of triangle ABCD will be 7 and 7, and finally you've got a 14. Next example we are going to illustrate is in 2008. So once again, so the question is a parallelogram, so which hints you about parallel lines as well as similar triangles. So you also have ratio BM to MC is 1 to 2, and you have given the area of triangle BGM is 1, and at last you're asked to find the area of parallelogram ABCD. So now I put the information in my picture. So I have So I have 1 to 2 here. An area of triangle BGM is equal to 1. The picture is a bit small. Okay, so now I've got the ratio BM and also MC. So in order to use the ratio 1 to 2 properly, I need to add a 9. Can you find it out this time? You may think of adding the 9 called GC, but then you cut the parallelogram into too many pieces. So that's why it's not a wise choice to cut the 9 in this way, but now I will be focusing on how you can use the similar triangles here. So we have BGM and also AGM. Okay, so you can see BM to MC is 1 to 2. So can you see also that, okay, point number 1. Point number 1. BM to, this time I will look at AD. So it's 1 to, can you find the number? Yes, it's 1 to 3. So secondly, so now we can find out, or we can find that BGM triangle is similar to a triangle. So note the order of the letters because they are important in writing similar triangles. So it should be DGA this time. So as a result, S area of BGM to S of triangle DGA is equal to 1 square to 3 square, that is 1 to 9. Which means that because the area of BGM is 1, so which is given by the question. So as a result, you can see that area of triangle DGA, so is equal to 9 cm squared. So that's our first result in reading a question. Now we come to the next job. Can I find the area of ABG or GMCD? My idea is area of triangle is easier to find, so that's why I try to look at ABG first. And here is my observation. I find that ABG, so it is standing on the base of AG, and it is next to the triangle BGM, which is standing on GM, as well as I know the area is equal to 1. So from similar triangles, let's come to point 3. So can you see that AG to GM is equal to, it should be about the similar triangles. You have known that it is ratio 1 and AD is ratio 3. So that's why AG is also ratio 3 to GM, which is ratio 1. So as a result, S triangle called ABG to S triangle BGM, so it's equal to 3 to 1 as well. And once again, as I have known that BGM, the area is 1, so that's why S triangle ABG is equal to 3 cm squared. So then we finish the second part. Finally, can you see that the question is about parallelogram? So that's why the triangle ABD should be is equal to S triangle BCD, so which is the same trick we have used before. So that's why S triangle BCD is equal to 3 plus 9, which is a 12, and as a result, the area of ABCD is equal to 12 and 12, so which gives you a 24 finally.